Quadratic functions. Discussion. We will start with the introduction to quadratic function. The polynomial function is defined by the function y equals a sub n times x raised to n plus a sub n minus 1 times x raised to n minus 1 plus a sub n minus 2 times x raised to n minus 2 plus so on a sub 0 times x raised to 0, where a sub n minus 1, a sub n minus 2, and so on, a sub 0 are real numbers, and n is a non-negative integer. It can be named based on its degree, like y equals mx plus b. This one is an example of a linear function since the degree is 1. Another, y equals ax squared plus bx plus c, where a is not equal to 0. This is an example of a quadratic function. And its polynomial function is on the second degree. Now let's have some example. Example A. Determine which of the following problems can be presented by a quadratic function. Example number 1. Nathan is 5 years older than Eliza. How will you represent Nathan's age in terms of Eliza's age? Let y be the age of Nathan's age and x be the age of Eliza. Then Nathan's age will be y equals x plus 5. Therefore, this problem does not represent the quadratic function since the degree is 1. Example number 2. A number is equal to the square of another number minus the same number. What equation best represents this problem? Let y be the number and x be the other number. So the equation will be y equals x squared minus x. Therefore, the problem does represent the quadratic function since the highest degree of this function is 2. Example number 3. Two consecutive positive even integers is being multiplied. What is the product? Let y be the product and x be the first integer and x plus 2 be the second even positive integer. The product will be y equals x times quantity x plus 2. As we simplify the given function by distributive property, our function will be y equals x squared plus 2x. Therefore, the problem does represent quadratic function since the highest degree is 2. Definition of a quadratic function. Part 1. Remember, quadratic function is defined as a relation written in the form of y equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. This general form of quadratic function can also be written as f of x equals ax squared plus bx plus c. F of x is read as f of x or function of x. Example B. Rewrite the following functions into its general form. Example number 1. Y equals negative 12x minus x squared plus 3x squared. That's the given. First, we need to arrange these terms into the general form. Remember, the general form is like this. Y equals ax squared plus bx plus c. You start with quadratic term, followed by the linear term, and then the constant term. So in this case, that would be y equals 3x squared minus x squared minus 12x. Next, combine like terms. 3x squared and negative x squared here are similar or like terms. So we can combine them. So in that case, 3x squared minus x squared, that would be 2x squared. So your answer will be, or the general form of this function is y equals 2x squared minus 12x. Example number 2. Quantity x minus 4 times quantity x plus 4 equals 9 plus y. That's the given. Multiply quantity x minus 4 and quantity x plus 4. So in that case, the result will be x squared minus 16. Then, transpose 9 to the left side of the equation. So that would be x squared minus 16 minus 9 equals y. Next, combine like terms. Since negative 16 and negative 9 can be combined since both are constant term, that would be negative 25. So the new function will be x squared minus 25 equals y. Next, applying symmetric property of equality, we could say that y equals x squared minus 25. So the function or the general form of the quadratic function is y equals x squared minus 25. Number 3. Negative xy equals negative x cubed plus 5x squared minus 8x squared plus x times quantity 5 minus 7 minus 4x. That's the given. First, you need to simplify what's inside the parentheses. 5 minus 7 is inside the parentheses and 5 minus 7 is negative 2. Next, simplify by multiplying negative 2 with x. So you arrive with negative 2x. Next, combine like terms. So we can combine 5x squared and negative 8x squared. We could also combine negative 2x with negative 4x. And with that, we arrive with negative xy equals negative x cubed minus 3x squared minus 6x. Next, divide both sides by negative x. As we divide both sides of the equation with negative x, we arrive with y equals x squared plus 3x plus 6. Number 4. F of x equals negative 1 times quantity negative 1 minus x squared plus x times negative 2. That's the given. First, we simplify what's inside the parentheses. Inside the parentheses, you have there negative 2 being multiplied with x. So let's start with that. In that case, that would be f of x equals negative 1 times quantity negative 1 minus x squared minus 2x. Since we multiply negative 2 with x. Next, arrange the terms into general form. So you will have there f of x equals negative 1 times negative x squared minus 2x minus 1. Next, use distributive property in simplifying the given. As we use distributive property, we arrive with f of x equals x squared plus 2x plus 1.